For this lesson, we're going to be going through all of our parent functions. So in mathematics, every function can be classified as a member of a family, and each member of a family of functions is related to the simplest or most basic function sharing the same characteristics. And this function is called our parent function. So what we're going to do is we're going to sketch the parent function of each of the following that we'll be studying in class. So we have 4 parent functions that it is very important for you to know. So the first thing we're going to be doing is filling out a table of values. Then we'll graph it and check our answer using Desmos, and then we'll state the domain and range of each of our functions. So let's start with our quadratic. And this one should be familiar to you because you did a ton of work with quadratics in grade 10. So how we fill this out is instead of writing an x in our first row, we're going to write a -2. So we're basically looking at f at -2 equals -2 squared, which equals 4. So that is what goes in here. And now you will continue to do that for all of the rows. Now that we have that filled out, we can graph it. So we have 0, 0, 1, 1, -1, 1, 2, 4, and -2, 4. And then I just connect them with a nice curved line like that. And then I just want to make sure that I label it on here. Now let's just check that on Desmos to make sure that, there we go. So if I go in here, y equals x squared, and it looks the same. So now we can find our domain and range. So if I look, there's nothing that's stopping my x's. So we'll have x is an element of real numbers. And as for my y's, all of my y's are above here. So that means that my y is an element of real numbers such that y is bigger than or equal to 0. Now let's do our square root function. So for this one, I'm going to be filling in my equation. So the first one is f at -2, which is the square root of -2. If you try to put that in your calculator, it's not going to work because we cannot square root a negative. So now you're just going to continue with the other ones. So f at 0 is root 0. So we have 0, 1, 2, 3. So now we can just graph that. So we have a graph that looks like this, and now we can check it on Desmos. Y equals square root of x, and again, it looks like this funny shape like that. Now let's look at our domain and range. So our domain, if I look, all of my x's are from 0 and going this way. So all of my x's have to be an element of real numbers such that x is greater than or equal to 0. Similarly for my y's, they're here and they just continue up. We don't have any below the x-axis, so we can write that y is an element of real numbers such that y is also greater than or equal to 0. Next, we will be looking at our reciprocal function. So again, we're going to start by filling in our table of values. So for our first row, we have f at -2. So that will just be 1 over -2, which is the same as -1/2. Then we have f at -1, which is just 1 over -1, which is -1. And this is the one that's a little bit trickier when we have f at -1/2. That is 1 over -1/2. And I'll show you how to do this fraction. So that's the same as saying 1 divided by -1/2, which is the same as 1 times -2 over 1. So that equals -2. And then you can just continue filling these out. Now, if you try to do this for 0, we'll have 1 over 0. And if you put that in your calculator, you should get an error because we cannot divide by 0. Now, if we continue the same way we were, we can fill out the rest of our table of values. Now, let's plot all of these onto the graph, and then we'll check it on Desmos. So we have -2, -1/2. Go. Like this, and then we're going to connect the curves like this. And if you notice, it has kind of a funny shape, and my graph never touches these two lines. And that means that these two lines are called asymptotes. So we'll graph it on Desmos because it'll make it a little bit easier to see. And I get that same funny shape, but if I look and I zoom in, my graph never touches the y-axis or the x-axis. It gets very, very close, but it never ever will touch it. So that is where we get our asymptotes. Now let's write all of that out as our domain and range. So for our domain, x is an element of real numbers because we've connected it with a curved line, but the only thing x can't be is 0 because of that asymptote. Similarly for our range, y is an element of real numbers because I connected my dots with a nice line, but y also cannot equal 0. Let's do our last one. So our last one is our absolute value function. An absolute value is written like this, and it describes the distance from x to 0, so it's always positive. Essentially, if we have a negative number, we just get rid of the negative and we write it all positive. So let's go through and fill in our table of values. So f at -3 would just be absolute -3, and then I just get rid of the negative. Same for -2, turns to 2, -1 turns to 1, and now we can graph it. So it's going to look something like this. And we can verify that on Desmos. And again, we get that shape. So let's write out our domain and range. So there's nothing stopping my x's. So I can just say that x is an element of real numbers. And then all of my y's are above 0. So I can say that y is an element of real numbers such that y is bigger than or equal to 0.